Hello folks, today we're going to look at another use of the grid method that we looked at on Wednesday, and that is to create remainders, which I think we didn't have to do last time because everything divided perfectly, but in algebra, as in life, not all things are perfect. So let's look at an example here. We want to do x squared plus 5x plus 8 divided by x minus 2. So we should know by now that this entails setting up a grid, and we are dividing by x minus 2, so that's going to be the rows, the columns of our grid, and we're going to obviously have to fill something in underneath. What goes where? Well, the biggest power goes in the top left. That means that this number here is going to be x, because x times x gives x squared, and this is going to be minus 2x. But we don't want minus 2x, we want 5x. So we want to add 7x to that, that'll give us 5x, means this is 7, means this is minus 14. And here we can see an issue that we previously haven't had. This says minus 14, but we actually want plus 8. So there is 22 that is currently missing from our answer. And that's all we really need to think about, that's our remainder. So the way we'd express this is that x squared plus 5x plus 8 divided by x minus 2 is equal to x minus 7, because that's what we get. I've just realised that should be x plus 7. Okay, carry on. Plus a remainder of 22 out of x minus 2. And that's it. That's the process. How is that equivalent? Well, another way we can look at this is we could rephrase what we've just written as being, so we're saying that x squared plus 5x plus 8 over x minus 2 equals x minus 7 plus 22 over x minus 2. Now if you were to multiply everything by x minus 2, you get yourselves to x squared plus 5x plus 8 equals x minus 7, x minus 2 plus 22, and that's the remainder that we just found there. So we found that if we multiplied those two things together, we need 22 more, so that is equivalent to our statement. But yeah, all you need to remember is the top line. Okay. As I've said here, this question can be phrased in a few different ways. This is another way the same question could be phrased. It gives us obviously our algebraic fraction. It says it looks like this, find a, b, c and d. And what we need to do is obviously divide the top by the base. So let's set up our grid. X and minus 3. Gonna need 3 rows this time, I think. Hopefully that's right. So we're going to start with x cubed. That means this is going to be x squared, this is going to be minus 3x squared. But we don't want minus 3x squared, we want x squared. So we're going to need to add 4x squared to that, which means this is 4x, it means this is minus 12x. But we don't want minus 12x either, we want 0x. You'll note that isn't part of the numerator, but you've still got to remember that it exists. Don't go straight to the minus 7 at that point. So we want plus 12x, which means this is going to be 12, and then this is going to be minus 36. But we don't want minus 36, we want minus 7, so we've got a remainder of 29. So our final answer is going to be that this division is equal to, triple equals to, x squared plus 4x plus 12 plus 29 over x minus 3. So I guess in the sense of answering the question, a equals 1, b equals 4, c equals 12, and d equals 29. Okay? How else can we phrase this question? Well, we could phrase it like this. Very similar to the one we just saw. gives us an expression like this, and what we can do is we can rearrange this expression to be a division. So we've got our x4 plus x cubed plus x minus 10. We're going to divide both sides of this identity by x squared plus 2x minus 3. And that will give us that this is ax squared plus bx plus c plus, and then the dx plus e is over a remainder of some sort. And this is the division that we need to do. Let's set up our grid. I'm not sure if we divided by a quadratic last time round, but you can. It's absolutely fine. You just put 3 columns on your table this time. And then you go through the same process that we've gone through a number of times. I am going to talk through it though because it's fun. Highest power goes in the top left. I'm going to need 3 rows, I think. Let's put them on to start with. Highest power goes in the top left, which means this is x squared, this is 2x cubed, this is minus 3x squared. And then we want to look along diagonals here. We don't want 2x cubed, we want a single x cubed, and this whole diagonal here is going to have to add up to that. So we'll write in minus x cubed to make that happen. We want to get to single x cubed. So this means this is minus x, this is minus 2x squared, this is plus 3x. But we don't want that, we want 0x squared. Remember that even though it's not written there, we still need to factor that in, we still need to go down the powers one at a time. We've currently got, again, thinking about the diagonal, minus 5x squared. We want to get to 0, so we need to add 5x squared to that. This means this is going to be 5, this is going to be 10x, this is going to be minus 15. Now what have we got so far? We have got 13x here, but we want to get to a single x. So our remainder is going to include take away 12x. And then we've got a minus 15, but we want to get to minus 10. So it's going to include a plus 5. So let's put that all together. We've found, using this identity, that this is equal to x squared minus x plus 5 plus minus 12x plus 5 over x squared plus 2x minus 3. And so we can take from that in terms of actually answering the questions. A is 1, B is minus 1, C is 5, D is minus 12, E is 5. Happy days. Okay, so I think that's basically all the different ways that this question can be phrased, but it can tie into one more topic, and that's partial fractions. So here's our example. We've got x to the 4, etc. as this, and it says just express this as a partial fraction. Now this is obviously slightly different from some of the other partial fractions that we've looked at so far. For one, the denominator is cubic, but that's fine, that can be factorized. But this is improper. So I've said, you know, if partial fractions are improper, what does improper mean? Improper means that the top power is greater than or equal to the base power. So it's not like in fractions, improper just means the number on top is bigger than the number on base. With algebra, it means the power on the top is bigger than the power on the base. So here we can see our biggest power is x to the power of 4, whereas on the base, our biggest power is x to the power of 3. That would make this improper. So what we're going to do is a standard division to start with. We're dividing by a cubic this time. X cubed minus 4x squared plus 4x. There's kind of an argument as to whether you should write plus 0 at the end here. It doesn't actually make a difference if you do, because this column will all be zeros, but just bear it in mind. You can write it on, it wouldn't be wrong. I think we're only going to need 2 rows this time because we're only going up to x to the power of 4. So let's get cracking. We want x to the 4. That means this is x. This is minus 4x cubed. This is 4x squared. That took me a lot longer than I thought it was going to. And normally at this point I'd say, but we don't want minus 4x cubed, but we actually do want minus 4x cubed. That's what we've got. So this diagonal here is going to have just 0x cubed, which means this is 0, and all these things will be 0 as well. 0x squared, I suppose, if you really wanted 0x. But that's pretty much it as far as that goes. We want x lots of this to start with. So what are we saying? We're saying that this fraction is equal to x plus, and then we need to think about a remainder. So what are we actually missing? We have got 4x squared on this diagonal, but we actually want 9x squared, so we need another 5. We want minus 17x, but we have 0, so we need to take away 17x. And we want 12, and we've got no numbers, so plus 12. That's our remainder, and it's all over x cubed minus 4x squared plus 4x. So you use this as sort of like our initial step, because what we now have is a, I guess, proper fraction. I don't know if that's the right word, which we can split up into partial fractions using techniques that you've done with Miss. Namely, we need to first factorize the base. So we can take out, in fact, let's just do this over here. This would be x, lots of x squared, minus 4x plus 4. That goes to x minus 2 all squared. And just bear in mind, if you do have a repeated root, we need to use it twice. So we're going to say that this is whatever, it's over x plus 2 squared. And so we can split this up into a over x plus b over x minus 2 plus c over x minus 2 squared, and then we can go through the same partial fraction process that we normally would. So we know this is equal to our fraction over here, so we could multiply everything up by x minus 2 squared, and we could get this is equal to x, I guess, squared, x minus 2 squared, plus x minus 2 squared, plus x minus 2. That should be an a here, shouldn't there? A b here. Plus cx is equal to our x to the 4 minus 4x cubed plus 9x squared minus 17x plus 12. If we sub in x equals 0, we'll get 12 is equal to, the only one that's going to come out is a, so it's equal to 4a. That would tell us that a is equal to 3. If we sub in x is 2, don't use red again. If we sub in x is 2, we're going to get 16 minus 32 plus 36 minus 34 plus 12 is the same as, so 0, 0, 0, be the same as 2c. So what does this give us? 52, 64, 60, 30, minus 2. So minus 2 is equal to 2c, and that will tell us that c is minus 1, and then you could pick another number to sub in at that stage. So we could substitute in x equals 1, I guess. And then obviously we know that a is 3 and c is -1, and this will give us 1 minus 4 plus 9 minus 17 plus 12 is the same as 1 times 1 plus 3 times 1 plus b times 1 times -1 minus 1 times 1. This will give us 10, 22, 4, 5, 1. 1 is the same as 1 plus 3 minus b minus 1. So that's 3 minus b. So we'll end up with 1 is 3 minus b. b is 3 minus 1, which is equal to 2. That took a bit longer than I thought it was going to. So our final answer as partial fractions would be x plus 3 over x plus 2 over x minus 2 and then minus 1 over x minus 2 all squared. Okay, cool. There's going to be some questions to do, but hopefully you've got the general hang of it. I think the more practice you put into this method, the better, and the remainder stuff is, it's just an extra step to what we did on Wednesday. Cheers, folks. See you next week.